Races. Okay. All right, let me go back over to Modo and we're going to start. Okay, so let's just start off today really quickly with a quick, short refresher of this whole replicator system, because replicators are important. In many ways, they are the foundation for everything that follows through the lens and with the conversation of particles and particle generation. Because at the core of a replicator is that point source, right? Those individual little vertices determines where the prototype is going to be generated within the scene itself. So let's just do it real fast. Let's walk through the process of creating these little prototypes. And I'm feeling a little weird today. So in a new mesh item, I'm going to make a teapot, and this is going to be the element that I'm going to replicate. Okay, the little Utah teapot, which will be kind of fun. And now we need some sort of point source. And let's just travel over to our item list real fast and talk about these point sources. And I'm just going to rename this mesh item point source just so we can visually understand its role inside of the setup that we're about to craft. Okay, a point source is nothing more than a whole series of vertices within inside of a mesh item. The location of those vertices is going to determine the location of a whole bunch of little teapots that are generated from the replica. Now, from our conversation last week, how can we generate all these points? I showed you guys like 3 or 4 different methods. Give me one of them. With the mesh, right? Because a mesh is really nothing more than a whole series of vertices all connected with some edge segments. So let's make a mesh, okay? And let's do something really silly. How about we do something like, oh, I don't know, like on a hippo. And yes, I'm going to use the hippo as the source for my replicator. So at the location of every single one of these vertices on my hippo, I'm going to generate a vertice or a teapot. So let's just do it real fast. It's a lot of teapots, and maybe I should not be doing this. I'm also going to make my teapot a little bit smaller. There we go. All right. So how do I add the replicator? Because I have both my point source, which is going to be the hippo, and then my prototype, which is going to be the teapot. So where do I physically have to go within the interface to generate this replicator? Add item, that's right, because the replicator is an item. It's a unique, discrete item within our system. So we'll go add item, and then it's under the particle system. Okay. One note, if you're using 601 at home or in other capacities, they've reshuffled the item list a little bit. Replicators used to be in the duplication category in the item list. In 701, they've created a new category called particles, and you can see that the replicator is now home in this category. So let's just do it real fast. Replicator. All right. So has anything changed within my scene? No, not a single thing has changed. What do I need to do to my replicator? Yeah, I love it. There we go. We need to modify the properties, and specifically under the instancing section of the replicator, you can see that we have to plug in specifically which mesh item is going to serve as the prototype and which mesh item is going to serve as the point source. Okay, so this is part of the manual operation of the replicator. So let's do it real fast. Prototype is going to be the teapot, and we're going to use the vertices on the hippopotamus as the point source for our replicator. And the moment I turn it on, boom, teapots. A lot of teapots. It does have chicken pox. That's pretty rad, actually. It is kind of creepy a little bit. One cool thing about working with replicators is we don't necessarily need to have the point source or the prototype active within our scene to generate the replicas. Okay? It's just pulling information from those areas to drive the duplication of all these teapots across the surface of my hippo. Okay? Pretty neat, huh? Okay, I like this. Yes, ma'am.
So I don't remember, but the replicators, they're not the actual mesh, are they? Would it take a long time to run that?
No, and that's the benefit of working with replicators, okay? Is just the rendering engine is only going to evaluate the geometry. We can't individually control these replicators at the item level, because we don't have 2,000 individual teapots, items within our scene. We only have 3. Okay, so it makes it very easy for our rendering engine to blast through this. Now, I'm not going to try to render this thing because, as many people told me during the live stream last week, that it went dark the moment I hit that render button, because my little iMac over here couldn't do both at the exact same time, broadcast and do some awesome rendering. But it is faster. It's a little bit faster. Okay, and it's definitely a whole lot easier to manage too. Okay, having 200 items or 2,000 items in our item list just turns into an organizational nightmare. Now we have 3, and I can just change the location of any one of these teapots by going in and changing the location of our points. Okay? Yeah?
Let's say you want to edit the teapot. Would all of them edit at the same time?
Let's find out. Let's find out. So let me go back. I'm going to reactivate my prototype. And just for purposes here, I'll just go in and just deactivate my my replicator just so it's a little bit easier to work. And oh, I don't know. Let's just make this section of our teapot. There we go. We'll just bevel it up. There we go. Now it's got a crazy lid on it. Then we'll further edit the shape. Oops. By beveling it in. There we go. So now it's drastically different. Let's turn off the visibility of our prototype. And the answer to your question, Jessica, is yeah, absolutely. And that's how that's one of the features that I really like about replicas, is that we get the same referencing that we got with instancing. Okay, we get the same workflow, but we also, it's made a whole lot easier because now I don't have to manage 2,000 items in my item list. Okay. I'm managing 3. This is something that we'd only want to do on geometry that we don't need to individually control. Okay? If it's not going to move within your scene, make it a replicator. Okay? It's really kind of neat. Excuse me. All right. One other thing. What if we wanted to have some of the replicas be teapots, others be, I don't know, something else? Okay? I went over this last week, and it's really kind of a neat addition to the replicator system, because what we can use replicators to do is to randomize the placement and which prototypes are being applied to the point source. Let's just check that out real fast. Maybe I want to have some of my replicas be these little teapot, and I want some of my other replicas to be, let me find something really, really geometrically light. How about, oh, I don't know, the chicken. Okay, so I want some to be the chicken, and I want some to be, let's figure out something else. I want some to be, oh, I don't know, an ear. Where's the ear? Yes. Very top? Yes. There we go. I love it. Okay, here we go. So, oh, let's make it just like a really weird thing. And we'll have some be ears, we'll have the eyeball, and of course, we got to have the teeth in there. There we go. This is going to be great. Okay, so instead of the ear, the eyeball, oh wait, the teeth is, shoot, let's do this. Okay, so we got the teeth top, teeth bottom. Here, we'll just do the teeth top. That's awesome. It's going to be awesome. What are you talking about? It's going to be great. Oh, I see how they've constructed this. Oh, bummer. You know what I can do is, like, just for illustration purposes only, I can just collapse all this geometry into one mesh item. There we go. Now it's contained in its own. Okay, so let's put all this into a group. Now I got to do this in item mode. Okay, so I'm going to grab my teeth, hold down the control key, grab my eyeball, which is also constructed of complex parts. So the same thing here. I'll just grab the pupil, cut it from one mesh item to another.
So even if you put a hierarchy in the group, it'll still count each item in the hierarchy?
I don't know. I really don't know. Explore that on your own. I don't know. I don't know. Maybe. I'm just going to try to keep my example real simple here by collapsing them, or by only assigning the parent of the hierarchy to the group. And so we got the teeth, the eyeball, the ears. That's good enough. Okay, so check it out. If we go up to this Groups tab at the top of our item list here, we can very quickly add in a new group. And once you hit that new group button, you'll get a cool little popover, and we'll just call this weirdness. And we want to create the group from the selected items within the item list. Okay. And there, on my weirdness group, if we click the little plus sign, we can view the items within that group, and there they all are. Okay. Now let's go back to our item list and start deactivating pretty much everything here. And let's revisit our replicator, because now our replicator, we're going to change. Excuse me. Let me jump over to model. We're going to change the prototype in our replicator. We don't want to replicate just a single object now. Let's see. Let's grab. Where's my weirdness group? There it is. Here's the weirdness group. Okay. You can see that Emoto puts that little puts little brackets around the mesh item, or excuse me, around the blue cube to signify a group. Okay. When we activate this, Moto's randomly going to choose items from that group and place it at each one of the vertices along my hippo. So it's a really great way to randomize things. Let's turn it on. Even know here? A whole Moto. Processor intensive. Here we go. While live streaming tends to be a little bit of an issue. Even from here, looking at the location of these vertices, some teeth, some are eyeballs, some are the ears. It's just kind of weird, right? But it's also kind of great. Okay, allows us to randomize the detail that's being inserted within the scene. This is really great for environmental stuff. I've used this a number of times for trees, right? Because you look at it, a forest of trees, it's not all the same tree, right? There are variations of the different trees within inside the forest. This is a great way to get different trees quickly without having to place them by hand. Okay? Replicating a group of items instead of just one item. And it is killing. We'll start a new. Oh, they're all that. Yeah. It is abstract, man. I'm dead. There it is. I love it. Hungry hippo. All right. That is pretty funny. Good job, Alex. Alex number 1. Alex so far. Got out in front today. I like that, Alex number 1. All right. Okay. All right. Let's. I want to nuke pretty much everything. I'll just start a new scene so we don't have to worry about the contents of that one. And we're going to make a new one. Okay. So from our kind of exploration of replicators, we can start building upon that and start looking at how we work and how we can use particles. Because really what we're doing here is that we're using the location of a point to determine the location of a replicated element. We're going to tap into that. Okay. Up until now, all of our points have been static. They've been on a single ground plane or across the hippo. Or last week when we were talking about surface generators, we were creating particles along the certain branches of our tree, right? But they were static. They weren't moving at all. Replicators can be used across a number, and I mean a number of different elements in our scene. Let's look at another one. The particle system inside of Moto, to put it simply, is awesome. Okay, this was the banner feature in 701, and they completely rewrote, if you will, the particle system for 701. We had a little bit of this stuff in 601, but in comparison, it's night and day. It's a completely different system, and it's fantastic. I actually happen to really love the particle system in 701. It's the easiest particle system that I've ever worked with, and I think it's really has a lot to do in part with the foundation of replicators. It makes generating cool stuff quickly. Okay, so let's jump into it a little bit. Okay, so in order to work with particles, in order to get our point sources to move, we have to go into our setup tab. Don't worry, we're not going to rig anything. Okay, so I know that a lot of you guys have an adverse reaction to the setup tab because you're still licking your wounds, if you will, from the rigging component of this course earlier this semester. Okay, don't worry about it. This is a much easier environment to work in when dealing with particles. Okay, We're going to go over to this particle subtab in our toolbar. Okay, so let's just jump down there real fast and start exploring all these different really cool things that we can build quickly inside of Modo. So here it is. There's all our particle tools. Okay, there's quite a number of things that we can do here quickly inside of the setup tab to get a whole series of points moving within our scene. Particles rely upon two very, very, very specific elements to be present within the scene. We have to have a particle simulation. That's kind of the brains of the operation, right? And then we also have to have an emitter. So you gotta get two things. We have to have something that tells the computer to generate particles, and then we have to have an emitter, which is really a method for the computer to kind of blast the particles out into our scene. Okay, think of it kind of like a fire hose. Okay, the hydrant is the particle simulation, and then the fire hose itself is the emitter. The shape of the emitter and the type of the emitter is going to determine which type of illusion that we're going to be able to create within the simulation itself. These are going to be simulated events. Okay, so go back a couple weeks in the Wayback Machine and start remembering how we worked with simulated dynamic and hard and soft body effects. Okay, we're tapping into that system. So particles inside of Modo are half dynamically created, half replicated elements. Okay, so we're kind of pulling upon about a month's worth of content here all in one spot. The easiest way to get a particle system into your scene is just to add an emitter. So if you examine the toolbars over here, you can see that we start off our entire workflow with the simulation. So as I mentioned, that's the most important thing. We've got to have a simulation in order for us to start our work. However, if we just add an emitter, a simulation is automatically going to be applied into our scene. I'm going to start the day by let's add in a radial emitter. Okay, so I'm just going to click on it. I've added one into my scene, and let's check out our Modo interface. Okay. So down here in our setup window, our OpenGL environment, you see we get this big sphere. That's the radial emitter. We'll come back to that here in a minute. Let's jump over to our item list real quick and talk about the new elements that have shown up here. So as you can see, we have two. It automatically created a particle simulation for us, and it automatically generated the radial emitter within our scene as well. So you don't have to go add a particle simulation by hitting that button that said simulation. If you just click on an emitter, a particle simulator is automatically added to your scene. Okay, let's click on our particle simulation here and examine its properties, because you're going to be coming in and out of these properties a lot. We're going to start with the properties in our particle simulator because there's a couple things in here that we need to look at first. Okay, our emitter is going to be blasting out a point. It's going to take all of these rules in here on the top part, so the particle simulation section of the properties, to determine how this particle, how this point, if you will, is going to behave. It's one of the many different factors inside of our system that will determine how a particle behaves. At its most simple form, we have an age. That's how long our particle is going to live, if you will, before it's terminated, before it's killed inside of our scene. So if you think about that, it's going to be on screen for 60 seconds, okay, before it dies. Okay. We also have the ability to tap into our dynamic simulation gravity system, which is kind of neat. We'll come back to that in a minute. So we can have our particles be influenced by gravity. Interesting, okay, especially when you want your particles to collide with other elements within the scene. We'll come back to that here in a minute. And then we also can change the acceleration rate, and that's really kind of tapping into the actual pull of gravity here on Mother Earth. Negative 9.8 meters per squared second is how much gravity we're being pushed down upon here on Earth. So we're simulating how things work out in the real world. We'll come back to drag a little bit later. That's a way for us to kind of change the velocity of our particles over time. I think for today, I'm going to increase. We also can control the visibility of our particles, and this is just purely inside the OpenGL viewport. I'm going to make my particles a little bit bigger so it's easier for you guys to see them both here in class on the screen and also in the live stream. Okay, because once we hit the play button, you're going to see a whole bunch of dots, and they're going to be very small. So let's just put this up to 2.0. All right. Let's play our simulation and see what we get. Okay, I want to hit the live simulation mode, this button right here, and let's see what happens. Particles. Okay, so our radial emitter is taking the information that's associated with it, and it's generating a whole bunch of dots, a whole bunch of particles, and they're all being emitted outwards radially from the center of our radial emitter, and this is the effect that we're getting. And I know it's kind of difficult at times to follow a specific particle because there's a whole bunch of them being kind of emitted here, but they will die after that 60 frame setting that we just explored a moment ago. So the simulation is going to determine how the particles are generated. Here we go. And then the emitter is going to determine where within the scene that they're allowed to go. Okay, and the direction that they're emitted. I have my radial emitter selected here. Stop the sim and look at its properties. There's a couple things down here that I want you guys to focus in on. Okay, the emission angle, or excuse me, the emission rate. This is how many particles are going to be generated per frame. So right now, 30 particles a frame, or a second, excuse me, 30 particles a second. That's a lot of particles coming out. We can increase or decrease this. Check it out. So if I run the sim, now I'm in the live simulation mode, and if I was to increase the number of particles, there you go. Now we're blasting out, what? Almost 3,000 particles a second. That's a lot of information. It's a ton of information, and you can see that they're just going forever and ever and ever. Pretty cool. Okay. So the emission rate is going to determine how many particles are going to be generated within inside of our scene. Let me stop the sim because I don't want to have that many. Let's put it back down to 100 and run the sim. Okay. What if I wanted to control? What if I wanted to control where or the direction that these particles are going to be generated along? Okay, that's where the cone angle and the angle spread are going to come into play. Think of this kind of like a fire hose. Okay, now we're figuring out the angle in which we're going to be emitting particles within our scene. Okay, right now at a cone angle of 180 degrees, it's kind of being emitted in a sphere. If I wanted to be emitted from a much smaller defined cone, let's put this back down. Let's move this down a little bit. You can see the emitter changing its shape inside of my OpenGL viewport. So now I'm at a value of 26.4 degrees. And let's stream it out. Let's do a live sim. And you can see that now we're not emitting in a circle. We're emitting along a very, very defined angle within our scene. Changing the angle spread is going to create some variation along the angle that the emitter will generate our particles along. So if we wanted to kind of soften that edge a little bit, we can increase that angle spread, and now we have some particles that are being generated precisely within the cone, and then some are being generated outside of the cone. So we're kind of blurring the edges, the fall off of, if you will, of our emitter by changing that angle spread. We get a tremendous amount of control over all the particles that we're generating within the scene. The cone angle and the angle spread are going to determine the direction. If we wanted to change the speed, now we got to start going down and looking at this initial velocity. Okay? The initial velocity is how fast our particles are going to be leaving the emitter. It's represented by this big arrow in the center of our emitter. The higher that arrow is, and the longer that arrow is, the higher the acceleration in the initial velocity. Right now, it's at 720 millimeters per second, or 750. If we were to increase that, now look at them. They're being emitted at a rate of 5.79 meters a second. So they're going fast. It looks as though we're not emitting very many, but these are just the ones that we can see because they're being emitted so fast. Okay? So the initial velocity is going to determine how fast our particles are going to be generated within our scene. The velocity spread, knowing a little bit about the angle spread, which is going to determine kind of a variation in the angle in which they're emitted, what do you think the velocity spread is going to allow us to control or allow us to achieve? Speed, yeah. That way we can have some that are emitting very fast, some that are being emitted very slow. Let's dump the velocity spread down to a value of 0 and see what we get. Now, it may be a little bit difficult to see. It is very, very subtle, but all of the particles are now being emitted at the exact same speed. Pretty cool. Pretty cool. So we get to control the speed, too, and the variation of the speed within the emission rate. Let's put my angle spread back down to 0. That may be a little bit easier to see. Sometimes it's really easy and to understand what some of the values of these systems are having, or the impact the values are having, by just like increasing the emission rate. Now we have like a fire hose here. Pretty cool. There's all our particles, and they all look to be moving at the exact same speed across the entire simulation. Okay, so if we were to go in and change that velocity spread a little bit, let's increase it to a couple hundred, something like that. Takes a second for it to catch up. But some, yeah, now we can see that some are moving faster than others, and the age of our particles is determining when they're being removed from the scene. When they're all moving at the exact same speed, they were all getting to the exact same point within the scene, and then they were dying due to their age, right? Now that some are moving faster than others, some are traveling a much larger distance within our three-dimensional scene before the age is terminating their effect within our scene. Kind of make sense? Getting it?
How it's dying down right now, sort of.
Yeah. Yeah, and some are moving very slow. So they're only traveling maybe 10 meters before they're killed. The others that are moving very fast, they may be getting to 60 meters outside of our emitter before they're killed by the system. Pretty cool, huh? Pretty cool. One other really neat thing about working with these particle simulations, let me dump this down to 1,000. There we go, and now it will slow down. Any change that we make into our simulation settings, or excuse me, to our emitter settings, will automatically be seen inside the OpenGL viewport. If you're using this first button, which is the live simulation mode, we can make changes to our properties and immediately see the impact of those changes inside of our OpenGL viewport. It's a really cool piece of technology, and something, to be honest, is unique inside of our 3D graphics industry. In addition, we can also begin to move the emitter around and see its role within our, or its how its change is affecting our scene. There we go. Now let me just, instead of doing item transform, let me just, there we go. So this is just the rotate tool instead of item transform. And you can do this all day, by the way. It's kind of like a fun little toy. Let's blast some particles off over there. Over here now. Over here. Whee! Okay, now I'm just playing. I apologize. You give me a fun toy, and I'm just going to play with it all day. Okay. So this live simulation mode allows us to prototype quickly how our simulations and our particle simulations are going to be generated within our scene.
Can you also change up the speed of how the particles shoot out? Like,
Yeah. Which channel over here is going to influence the speed? Velocity. The velocity is going to determine the speed that our particles are leaving the emitter. So if I was to lower this quite significantly, let's put the spread down to 0. Let's put this down to like 300. Yeah. Oh, that's 300 meters. I wanted I wanted 300 millimeters per second. There we go. Now they're moving much, much slower. Okay. Much slower. And if I continue to dump this down to 70, now they're just creepy crawling along as they're being emitted within our scene. Pretty cool. Pretty cool. The power of the Modo system relies both on the technology on the back end that's driving the generation of all these particles, but also in the variation, or excuse me, in the variety of emitters that we have access to within our system. This is the radial emitter. Okay, but we have 3 other emitter types that will allow us to generate particles in some unique ways. Let me stop my simulation, and I'm going to do this. Let's do this. Now, in order for us to have any sort of particle simulation, obviously we have to have a particle simulation item. However, what if I generate maybe like I don't know, a surface emitter? Okay, so I now have a surface emitter in the exact same scene as a radial emitter. Well, which emitter is driving the simulation right now? I don't know. Let's go find out. The best way to work with the particle system is to utilize the schematic window. And I like the schematic window. It's really kind of neat, and it allows us to very quickly understand how our particle simulation is being created. Let me show you what I'm talking about. Up until now, I've been working inside the Setup tab with the top window full screen, and I know that just by seeing this little gold arrow in the upper right-hand corner of my OpenGL viewport. That means that the current window is maximized inside this area of our interface. If I click that gold button, now our schematic window pops in. Our schematic window down here at the bottom will allow us to visualize the connections between all of these different elements. In every sense, this is a nodal workflow, and you'll see that here in a second, okay? And let's just do it real fast. What I want to do is that I want to see visually the flow of information from one element into another. Because ultimately, the particle simulation is generating a tremendous amount of information, and all that information is flowing into the emitter, and its rules and regulations are telling the computer how and what direction all of those particles need to be blasted out within our scene. So let's get access to that. I want to see that flow of information. I'm going to select my particle simulation from my item list, and I want to drag it down into my schematic window. And we get our first node, and there it is. That's what it looks like. If you haven't worked with the nodes inside the schematic view, let me give you a small little tour. On the left-hand side of the node, you see a whole series of diamonds. You also see some diamonds on the right-hand side of the nodes. The left side always represents the input information to that node. The right side, take a guess. Output. Okay? Input of information, output of information. If you look closely, that little diamond right there is gold. It's also connected to the operator's channel. So what we see on the interior of the node represents the information that this node is responsible for. Whenever you see a gold diamond, that means that there is a relationship to another element within inside of our item list. If we were to double-click on that node, you can see that there's actually 2 bits here that are flowing in to my particle simulation. We can see that we have the radial emitter. This little purple this little line here is the noodle, and yes, it's officially called the noodle. That is the technical term, the noodle. And then we also have our surface emitter connected into our particle simulation. Well, I don't want my radial emitter to be influencing how my particle simulation is being created. Okay? I want to remove the connection between my radial emitter and my particle simulation. How do I do that? Let's take a guess. Let's grab it and detach it. Okay? Now we can detach things by grabbing the diamonds. Okay? Actually, I'm grabbing the input. Now this one has two things flowing into it, so this is maybe a bad example. We can also select the noodle. It goes orange. And then hit the delete key. Not the backspace key, the delete key, and we can remove this radial emitter from influencing the output of our particle simulation. So we can do that again. So for example, if I wanted to plug in the radial emitter into the operators of my particle simulation, is grab the diamond, drag out a noodle, and plug it in. They've done a lot of really great work in the schematic viewport here in Modo in 701. I think the strength of the schematic viewport is a direct reflection of the relationship that Modo now has with the Foundry. The Foundry has a whole series of products where this is your work environment. It's just all modal based. And they have a very, very, very strong series of tools that allow that to happen quickly. And we're finally starting to see some of those flow into Modo, which is pretty cool. So I'm going to plug in my surface emitter into my operator. Okay? And it even goes green, which I think is really great. Woo, that means green is go, right? If I drag over here to another one, let's see, there it goes. It goes red, so we can't plug those into each other, which is kind of cool. So plug it in there. Let's play our sim, see what we get. No particles. Why not? Well, it's plugged in. Surface emitter is plugged into the particle simulation. We don't have a surface. Okay. Now check out this surface emitter. It needs some sort of emission source. The surface emitter is physically a piece of geometry, and at the location of every single vertice on that piece of geometry, we're going to generate particles. Okay? So for the surface emitter, we have to have some sort of polygon that's going to serve as the emitter. Let's make one real fast. How about we just do, oh, I don't know. Let's pick something easy. Let's just do a sphere. I think that's probably a good idea. Okay, there's my sphere. Awesome. Let's change it to advanced OpenGL here. There we go. And let's drag in that sphere, which is its own dedicated mesh item, into my schematic. There it is. Okay. Now we can plug in the sphere as the emission source for our surface emitter. Boom. Okay. So now when we run our particle simulation, awesome. Okay. If you look very, very carefully, it's kind of hard to see, but we're generating particles across the surface of our sphere. Let's do another source. Instead of doing a sphere, let's do a cone, because a cone may be easier to see what's happening here. Let's do a cone. How do I delete the connection between the sphere and the surface emitter? Yeah, Kaylee, go ahead. Click on the noodle. Delete key. Now we've removed it. If we play the sim, no particles being generated within the scene. If I grab the output node of our cone and load it in as the input source for my emission source channel, let's turn off my sphere so you don't see it. Yeah. Now we're emitting particles across the entire surface of our guy. Pretty cool, huh? So we have a lot of different emitter types within inside of our scene. There's some pretty cool effects that we can generate just based on how or where and how our particles are being created. It's pretty rad. So a radial emitter is just going to emit particles in a circle, right? And then we get to control the angle of emission through a channel in our properties. Our surface emitter type requires a specific piece of geometry within our scene, and then we hook it in to our surface emitter to emit particles along that line. This is really cool, especially if you want to have particles being created along a very custom location within our scene. We can define that with a piece of geometry. Okay, the last one that I want to talk about today, and we're not going to get to source emitter because that's a completely different conversation, is curve emitters. So let's remove all of this stuff from our scene. I don't want the surface emitter anymore. Oops. Let's do that. Let's get rid of this connection. Get rid of that connection. I hit the wrong button. Shoot, we can even select all of these guys in here. Right mouse button, drag out a marquee selection box. And if you right click on them, we don't want to delete them. But check it out. We can remove the nodes from our schematic so they're just not populating our scenes. We'll remove them. We didn't delete them from our item list. You can still see them chilling over here in our item list. Okay. However, I am done with them, so I'm going to delete them. Okay. So now all I have is just my particle simulation. We're going to talk about the curve emitter. And the curve emitter is very similar in function to that of the surface emitter. Okay? In that, it needs a source. It needs a physical curve to generate the particles along in our scene. Curves are special items inside the Motoverse. We've used curves in a number of different capacities this semester. And I think most recently, we used curves in combination with cameras to create kind of railroad tracks for our cameras to cruise down within our scene, right? That path constraint thing. Well, curves, because of their awesomeness, can also be used as part of the generation of particles within our scene. Okay, check it out. This is actually really kind of neat. I'm going to go over to my model tools. Excuse me. I'm going to go over to my model tools, and I think I'm going to make, in a new mesh item, I'm just going to make a Hermite curve, because I'm a big fan of Hermite curves. And I'm just going to click, 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 something like that. Create a nice curvy little guy. Okay, there's my curve. Haha. Fantastic. And let's just call this mesh item curves. Cool. I want to turn off my grid too. We don't need to see my grid. All right. So let's drag my curves mesh item down into my schematic and load its output as the emission source for my curve emitter. All right. And now we're only blasting out particles along that curve. That's pretty cool. Check out this. Let's look at some of the details of the curve emitter in our properties tab. And I think you're going to find that the awesomeness of the curve emitter really comes in the parameters, because this is kind of cool and neat. But if you think about it, this isn't really too dissimilar from that of a surface emitter, right? I could have easily created a strip of polygons that match that entire shape and emitted particles using the exact same system. Curve emitter is pretty freaking rad though, okay? I like curve emitters a lot because of the customization that we can craft quickly within inside of the properties. Let me grab my curve emitter. And of course we get the same emission rate. We can even randomize the seed value here to create a new thing. But this is actually kind of neat, this distribution gradient. We can basically define at what areas along the curve we want particles to be generated from, okay? So for example, maybe I only want particles being generated at the front part of my curve, and I don't want to have particles being generated at the end. This gradient over here, this distribution gradient, is going to control at which point along the curve we're going to generate particles. Check it out, okay? Let's go in. This is the new inline gradient editor in 701. And you can automatically see, or you can see that it's automatically pulled in the distribution channel along our curve. Where it's white within our curve, we're going to generate particles. Where it's black or has a value of 0, we're not going to generate any particles, okay? Let's just add a keyframe in here. I want to middle mouse click on my gradient, and I want to take this value down to 0, okay? We have a nice transition between a value of 1 and a value of 0. Let's watch how that's influenced how our particles are going to be generated within our scene. Yeah, check it out. If you look very closely, the distribution channel over there is determining where particles are going to be generated along our curve. And it's also controlling at which rate. The front end of our curve, we're generating 100% of the emission source. And then we're transitioning between these values to a value of 0, kind of right down there in the center. And if you look at the end of where our particles are being generated, we're only generating a few particles a second versus a lot, okay? If I change the position of that keyframe, you even see it growing. Really neat, because now we can animate the emission of particles flowing along a curve very nicely. Okay. What if we only want to have particles being generated in the center? You got it. Let's change how we're keyframing this, and we can continue on. Okay. So instead of having 2 keyframes, I'm going to need to have a couple. Okay, so over here at the beginning of my curve, I want it to be off, and then I want to have it be on here in the center. And maybe I only want it to be a small band, something like this. There we go. Let's play the sim. Yeah, there we go. And now we're only generating particles along that center section. Curve emitters are great because we just get a tremendous amount of control as to where our particles are going to be generated at any point within our scene. Very cool. Very cool. All of the curve types are supported. So if you're using a Hermite curve or a Bezier curve to generate your particles in tandem with the curve emitter, you're going to be able to get this level of control. Yeah. Middle mouse button. Middle click. Yeah, middle mouse button click to generate a keyframe. But the fun doesn't stop there with curve emitters. Okay, check this out. This is actually really kind of neat. One other thing, and I forgot to mention this about all emitters. If you look very carefully here, if I look kind of down my line, our particles are being generated on the actual curve itself. Well, what if I want the center part of my curve to be kind of hollow? I can push out the area in which at which the particles are going to be generated. That's the role of this inner radius and outer radius. Okay. And a couple of our emitter types have this radius value. It's also available to us on the radial emitter and the surface emitter, I believe. So let me stop the sim. I'm going to just pump this up a little bit. Let's do, I don't know, 200 millimeters. Maybe difficult to see. Let's really pump it up. And then we'll stop the sim and start it over again. Yeah, now they're not being generated on the curve. They're being generated 2.5 meters from the center of the curve. So we've kind of made like a hollow center, if you will. Okay, just a different effect. Just a different effect. We're in the driver's seat though, as to where these points are being created within our scene. Okay, let's put this back down. All right, and the outer radius is basically going to create kind of a feathered edge, just adding some randomization. So we can have some particles being generated on the curve, some particles being generated off the curve. So it's kind of like that cone angle feather that we were talking about earlier. All right, however, I think what I'm going to do is show you this. This is kind of neat. What if we had another curve into the mix? Or what if we have, I don't know, 4 or 5 curves at play here? There we go. So now I got 3 separate curves all on the same mesh item. Maybe at different points within our scene, I want to generate particles at any number of these curves in my animation. Well, check it out. If we go back to our curve emitter, we get to determine which curve is generating the particles by this curve index. Okay, this is pretty neat. Watch what happens now. The curve index value of 0. And with all curves active, we're going to emit particles everywhere, okay, across all curves. However, if we use all curves off, the curve index now becomes the driving force as to which curve within inside of our mesh item is going to generate these particles. There it is, okay? What if I change it to curve index number 1? Boom, now particles are going to be generated over here. These will all die off here in a second. There we go. If I go to curve number 3, pretty cool. Pretty rad, huh? Just a lot of control as to how these curves are going to influence our simulation in the long run. I like it. It's a lot of fun. It's a lot of fun. However, the one thing that our curves kind of really don't have at the moment is any real sense of gravity, right? They're just kind of like floating out into space. What if we want to create rain or snow or fire or smoke? Now we want to have our particles be influenced by gravity so we can push and pull them in very reproducible manners. Let me stop the sim here. And I think I'm going to nuke everything that I have at the time being and just start. And we're just going to start with a radial emitter. Let me add in a radial emitter. There we go. There it is. And I'm going to change the cone angle a little bit. I'm going to lower it down so it's just kind of blasting particles outwards, up, like that. There we go. Pretty cool. These particles are not being influenced by any sort of dynamic effect. Okay? They're not being influenced by gravity. What if I want my particles to be influenced by gravity? Pop quiz. What is determining or what is generating all of the particles inside of our scene? The simulator, yeah, the particle simulation item in the item list, okay? That's what's determining the generation of these particles, okay? If we go to our particle simulation item, one of the elements that we can access and add into the mix here is use gravity. Okay, let's turn it on. Let's see the effects here. Use gravity. Oh, I got to stop my sim. That's one thing that doesn't automatically update. So now, use gravity is turned on. Let's play the sim. Yeah. Now, they're actually being spurted up. And then once they get to a certain point within the scene, they go up, and then they start to curve out like that. You can see this at play a little bit more easily if we increase the emission rate on our radial emitter. Let's put it to like 1,000. There we go. Okay, pretty cool. Let's also change the initial velocity to something a little bit higher. There we go. And now we're creating kind of like a little water fountain effect. It's pretty cool. It's pretty cool. I dig it. I dig it a lot. Kind of fun. Kind of fun. All right. Questions so far? Everyone good? Kind of getting it, understanding it? All right. I'll tell you what. It's almost 3 o'clock. I've been yakking for about an hour and a half. Let's just take a break, okay? And then I'm going to come make your brains hurt. All right. Let's do it, shall we? Let's get back to it. Now, I've gone ahead and just started my sim, and this is where we left you. Okay. Up until now, we've been spending a lot of time talking about how to create particles. Well, I want to control how to terminate particles. I want to kill some particles now, because right now I'm getting my lovely kind of water fountain-y effect here, but they're falling forever. The only thing that's determining and controlling when these particles are going to die. There they are. Okay, they're all kind of generally dying down here. Is the age, the maximum age of 60. This is a when. So after 60 frames, particles are going to start to die. We can extend that age by a number of frames. And so if we extend it to like 10, some particles would die at 60. Some particles would die at 65, and other particles would die at 70. So we're creating some additional randomness in when the particles are going to be terminated. But I don't want a when factor. I want a where they're going to be terminated. Maybe I want to influence, maybe I want these guys to fall onto a ground plane and then terminate the moment that they hit the ground plane. In order to control where our particles are going to be terminated, we're going to create a particle terminator. And this is something that's really kind of neat. It's interactive. It ties into our fall-off system that we've played around with earlier this semester. Let me zoom out real fast and stop my simulation. Okay. So there's my emitter way up over there. Let me go back into my particle tools. And we're going to add in a terminator. Terminators are really cool because they get to control where our particles are going to be killed. Okay, let's add it into our scene. And I'm also going to drag it into my schematic, just so we can start to understand the flow of information here. Okay, a terminator is classified as an operator, a particle operator. It's basically a modification of our particle. Well, I shouldn't use modification because then there are also particle modifiers. That's the wrong terminology. But it's an influencer. It's going to influence how our particle simulation system is going to generate our particles. Okay. A particle terminator by itself isn't really going to do anything. Okay. Let me show you what I'm talking about. You can see it just chilling down there in my schematic. This is the particle terminator. And if we hit the play button, there we go. There's our stream of particles as they're flowing down our scene, and they're still generally dying at the bottom of my frame down there. Okay. In order for our particle terminators to work, we have to generate a shape, and specifically, we have to generate a fall-off, which is why we have all of these buttons at the bottom of our toolbar over here. We're going to generate a fall-off, not a force. This is what happens when you look at force and you mean to say fall-off. Okay, I'm going to stop my simulation, and I'm going to add, let's just do a capsule fall-off. Okay, and there it is. There's our capsule. It's just a three-dimensional plane or a three-dimensional capsule. If you think about this, this really is a piece of geometry. It's just not drawing all of the surfaces. So I want to make this bigger. It's a fall off. Okay, I'm going to add fall off, capsule fall off. Okay, we can make it bigger, and let's put this bad boy down below our particle simulation. Okay. Now, whenever our particles touch the surface of that capsule, they're going to die. Okay, they're going to be terminated and removed from our simulation. Let's play it. There they go. Boom. You know, it may be a little difficult to see because the stream of particles is probably a little bit too big at that point. So let me just make this bigger. Oh, geez, I'm a dork. I was like, why isn't it working? Because I forgot to plug it into my terminator. So I've added the fall off, but I forgot to plug it into my terminator. Oops, my bad. So we're going to take the output of my capsule fall off and input it and assign it to the input of the shape channel on my terminator. And now it should work. Let's just do it. Let's see what happens. Let's see. Nada. Why isn't this working all of a sudden? What did I do wrong?
What is it supposed to look like?
It's supposed to, let me see here. Terminator shape. hold on a sec. Why isn't this working? Let me figure this out here for a second. Yeah, the moment the particles touch it, you know, maybe we're seeing it, but it's just an optical illusion. This is a three-dimensional particle field. So let me just scale this way and this way. Now, if I was to look down this angle, let's see what we can see. No, they're still cruising through the center. Awesome. So that was an epic fail. All right, why is this no working? There's my terminator. Let's do only to new particles on my terminator and see if that makes a difference. No. Why is this not working the way it should be working? Fall off enabled, yeah. Okay, let's do this. Let's not use the capsule fall off. Let's use the radial fall off. We'll load this in. Yeah, I'm pretty sure it's that one. Into the shape. The terminator. Kind of a cool word to say, terminator. There we go. There's my radial fall off. This will be like a Death Star here, hopefully. All right. Now, the little punks. Why are they not doing what they should be doing? Well, that isn't very much fun now, isn't it? I have missed something in here, and I don't understand why this is not working. This worked when I prepped, and I don't understand why it's not working right now. I don't think so. Not to my memory. Yeah, deform meshes. No, that's not what we're trying to do here. You know what? Benefit of the doubt, though. No, I didn't think so. Huh. Well, that's a bummer, isn't it? It is. It is. Terminator. Particle sim. Yep. No, it's got to be the Terminator. The Terminator is the one that determines what dies. However, maybe we can do. It works on so many different levels, does it not? Here, let's try Austin's suggestion, and we'll add in a sphere, and then the output of that sphere's shape. No, yeah, I didn't think so, because this is a channel to channel. No, I'm like 100% sure that it's a fall off. And
It kind of works if you put the sphere, or you put the emitter inside the sphere, it kind of traps somebody.
we're not trying to trap them. We're physically trying to terminate them. We're trying to physically kill them. Okay, you know what? Whenever I run into a problem, I go start referencing the documentation. And this is actually a good opportunity for us to once again revisit where you can find specific information about problems. Under the layout and simulation section, here's all the particle stuff. And let's go under particle simulate. Nope, that's not it. There's a section in here. What did I miss? Terminators. Yeah, see, I had it right. Okay. Interesting. Let's give that a go. Maybe. Let's get rid of that mesh. Replug in my radial fall off. I think, I don't know, I don't think so, but actually it is working for me now because my radial fall off is inside of my emitter, and I'm not emitting a single thing. So that's an indication that it's working. Maybe, just maybe, then when I leave it, yeah, okay. Let's do this. Let's invert it. Now it's affecting everything except the inside. Nope, that's definitely not it. Okay. Ah, I think it's solid core. That's what it is. I totally forgot about this. This is actually cool. Okay, right now, the inside of my sphere is hollow. Okay, and it's only the particles that hit the dead center of my sphere are being killed. Okay, if I was to change the core to 100%, then I believe the outside of my, now just purely the outside of my terminator is going to kill particles. No, I was wrong. Never mind. I don't know what I'm talking about. It's Friday and my brain is mush. What is going on? This is kind of crazy. This is really irking me now. Linear to work? Why isn't this one working though? Okay, let's try linear. Let's get this one out of the mix here. Let's, yeah. Kind of works. All right. I'm hell-bent on getting at least one of these terminators to work today. Okay, so now I have a linear fall off with inside of my scene, okay? And let's move this around and get it going where I want. And if I remember correctly, let's run it now. Let's just see if it works, okay? And the angle of my fall off is going to determine where they're going to generate or where they're going to die. Yeah, see there it works. Jeez. So it does work, okay? Because as the particles are getting down and touching the bottom of my linear fall off, they're killing themselves, okay? And let me just go into item mode here, and I'll run my sim. And if I move this up and down, you can see that I'm interactively changing the level or the place at which the particles are killing themselves within our scene. Now that also brings in some inspiration. It's using the linear decay shape. You can also ease in and ease out, so do more of kind of a ramp. Kind of cool, kind of a variation. Some are being killed way off over here. Others are being killed kind of towards the middle. Let's do this. Let me get my radial fall off back into the mix here, because I really want this radial fall off to work, darn it. Because it is kind of cool to see it working when it's working. Okay, there we go. Decay shape. You said inverse power? Gaussian? None of them are working for me right now.
If you invert it and put the sphere over it, it keeps it inside. That's all I can do.
Yeah. Because now, see, mine's not even working like at all.
Press invert.
Yeah, and now it's the normals of the fall off are flip, and then when it touches the inside, the particles die. I don't want it to do the inside. I want it to do the outside. I want them to. This is really driving me crazy. I'm going to figure this out. Okay, it's not the strength, because it's at a value of 1,300. See, I've never had to work with this decay shape before. I've always just plugged it in and it's worked. Interesting. Okay. Now, one of the things I've learned from being a teacher is that whenever you prototype something on two different machines, look for the differences between those two different machines. Because I was actually working on my laptop earlier. Let's see if I can get it to work here. So just talk amongst yourselves for 2 seconds while I completely do this exact same thing. Okay. I want to add in a terminator now and a radial fall off. Fall off, terminator. Okay. Close. Hold on a sec. I'm going to figure this out, damn it. Well, this is kind of melodramatic, isn't it? Anticlimactic. Yeah, I know, seriously, right? Eh. I don't know. I'm punting on this one. I have no idea why this is not working on the radial one, but it's totally working on the linear one. That is aggravating. And it's really cool, too. It's aggravating that it's not working. Okay, well, anyways, it is what it is. I'll continue to do some investigation over the next week, and I'll report back to you guys next week to figure it out. Oh, let's check it out. Let's look at Austin's screen, see what he got. You're what, 4 or 5, Austin? 4? Yeah, that's it. That's it right there. All right. So what do you have? You get your strength just dialed up, and that's about it, right? The decay shape. Okay. Let me see if I can do that. Maybe I had my strength up at like 1,300, and it wasn't doing a single thing. Okay, let me change my decay rate up to 400 and change my decay from smooth to Gaussian. Yeah, still not doing it. Still not doing it. Okay, I don't know what I've screwed up here. I'm sure it's user error. My mind goes a little loopy on. Is it? You know what would be the indicator? Because it's kind of confusing here visually to see the impact of these particles. What I'm going to do is I'm going to go to my simulation. I'm going to turn off gravity, and then I'm just going to rotate my my radial emitter to blast particles at my guy. There we go. Kinda. Yeah, it's kind of working. Yeah, they're going around it. So in this case, it is working. Maybe it was just an optical illusion and it was working the entire time. Cool. Cool. If I change this back to smooth, what happens? Yeah. Let me narrow it down. So that's a good idea. There we go. There we go. Now it's working. It was just an optical illusion. It was working the entire time. Happy Friday. Yay. Yeah, because I'm using like all the default settings here now. Put this back to 100. Yeah. Okay. So it was just an optical illusion. It was working. I don't have to write a scathing email to Luxology now. No, it is working. And this is actually one of the cool things about the fall-offs is that we can move them. Okay? We can move the fall-offs and influence the emission of our particles. So we like go in and then now we're killing them. That's kind of cool. Make like smoke signals. Boom. Cool. Darn you optical illusions. Okay, so actually that brings up a really good point. So a lot of times working with these particles, it's really difficult to manage and understand exactly what's happening in the scene, right? Because we're seeing a whole lot of points, and it's really easy to get confused. So what if I don't want to have points? What if I want to have a whole bunch of cubes? What if I want a whole bunch of cubes? What if I want my little fire hose here to be blasting out a whole bunch of cubes? How would I do that? Replicators, right. Let's plug it in. I mentioned earlier that the replicators are really controlling what's going to be drawn in the scene. So let's go add item, particles, replicator. And now we need a prototype, and let's just do a cube. There it is. Okay. And in the replicator, let's go do it. Let's plug it all in. So the prototype is going to be the cube. The point source is going to be the particle simulation. Okay. Particle simulation now. Cubes. A lot of cubes. It's spraying cheese. I love it. Let's turn my emission rate down to like 30 and do it again. Now we can see with a little bit more information what's specifically happening. And shoot, if we even go grab my little radial fall off, I can turn them off. Yeah, now we can see them more easily being destroyed as the particle is hitting the outside of my radial fall off. Pretty neat, huh? Pretty neat. I like working with the particles inside of Modo. Any mesh item. So if I wanted to, I could have a prototype of a teapot and then blast a whole bunch of teapots out into my scene. Okay. Huh? Blast rhinos? Challenge accepted. I'm gonna break the live stream. Let's find out. Let's keep this example pretty simple because I think the rhinos would bring my computer to a crawl. But let's add a little bit more complexity into the mix by instead of replicating just a single point or single prototype, let's do a couple more here. Let's do that, and we'll do that, and we'll do a donut. Why not? Donuts are fun. And let's get all of my parts and pieces close to each other because I'm actually going to make them different colors. I'm going to create an item mask for each one of these. I'll make the donut green. I'll make the sphere. Oops. I'll make the sphere red. Go, and the cylinder will be blue, just so we can visually separate them pretty quickly. All right. Let's grab all of these, throw them in a group, new group. What's the name? We'll just call these shapes. Here it is, groovy. Deactivate the visibility of them now. If we go into our replicator, the prototype is going to be the group, not the meshes. This is going to be a little crazy. Let me turn on to show replicators. Go, and let's see what we got. So now we're getting some of them being the donuts, some of them are the spheres, and some of them are the cylinders. And as they touch that fall off, they're being terminated. They're being removed from the scene.
So it's only if the particle touches. So the outside mesh of the cube or the sphere, even if it passes through the fall off, will remain as long as the particle is protected.
You got it. You got it. If we wanted to generate collision events from the outside of each one of the prototypes, we'd have to make them rigid body dynamics, okay? Or have to add that rigid body dynamic tab into the mix there. Because in order to generate surface collisions, which is different than a particle collisions, the dynamic engine and that solver come into play. A little bit more advanced, but we can absolutely do it. That kind of gets us into the complexity of the schematic window, because then we need to have two different simulations talking to each other and sending information back and forth. It gets incredibly complex pretty quickly. We're not going to go into that because that really would make your brain hurt. Okay. I do want to show you one other thing here, because right now let's change some of this. Let's get rid of these fall offs and simplify our scene. The last thing that I want to show you today is kind of an introduction, if you will, to particle modifiers. Particle modifiers are pretty neat little elements. I want to keep my replicator. Get rid of this fall off. Let's just make sure yeah, okay, great. I'm going to go into my simulation and turn on use gravity. There we go, and now they're falling. Okay, now it looks like they're coming out the end of the fire hose. Let's give our radial emitter a little bit more spread here. So we're blasting out kind of a much larger angle. But one of the things that we haven't really started to achieve yet is any sense of rotation, right? These things are just falling. They're not rotating as if they should be weighed down by something. Okay. Well, in order for us to extend our system and to physically modify how these particles are behaving within the simulation, we have to add in some really cool particle modifiers. Okay. And particle modifiers are pretty rad. Well, let me take this. Do you want to look at particle modifiers, or do you want to look at dynamic colliders? Do you want to see our particles bouncing off of things? Yeah. Okay. Let's do dynamic colliders first. Okay. I'll give you the option here. Dynamic colliders. All right. Let me add in a piece of geometry. Let's do the sphere. Okay. And in component mode, I want to make this sphere quite large. Go. Back in item mode, I'm going to bring this down, and I just want to see how this is going to affect our scene. Okay, great. Just want to make sure that my sphere is in there, and then, okay, great. All right, so there is my sphere. Pretty rad. I want to have all of my particles bouncing off the surface of my sphere, and this is actually kind of neat. And what we need to do in here is add a dynamic collider into the mix. Okay, so I've just added one into my scene. I want to grab it inside of my item list and drag it down into my schematic, because our dynamic collider is going to start generating some really cool things. Just want to expand my entire network here, just so we can see exactly what's going on. Okay. Let's just play our sim as is. Yeah, so we're not getting anything yet. Why not? Yeah.
Is it not connected to the sphere, the dynamic collider?
Not so much that, but our dynamic collider really is not getting any sort of information fed into it, right? What if I was to go up to my sphere here and apply a little apply a little, I don't know, passive rigid body action to it. Okay? Now, the sphere is a dynamic element. Okay? We can see that it's being fed into our solver. And if we were to play it now, let's see. Still nothing. Oh, bummer. Let's see. We want it to be a passive rigid body, because if we were to make it an active rigid body, it would just fall. Whoa. Okay, we want it to be a passive rigid body, but why? Well, I think I got to put this in. Hold on a sec. Why is that not getting sent the way it should be sent? Hold on a sec. This is what happens when I do something different than what I prepped. All right. Say again? Maybe. Maybe. Let's see what happens when we add it in. The particles should be bouncing off. The particles should be bouncing off the surface of my sphere. Let me make a new scene here real fast, and let's simplify it down. Sometimes whenever I get stuck on something, it's like, well, let's just let's just make it simple. Okay. Radial emitter. There we go. Let's go into the particle simulation. Let's just add a little gravity. There we go. Now they're all being pulled down to Mother Earth. Let's go grab our dynamic collider. Let's just throw all this in. All right. And what's going to be the dynamic collider? Well, let's make it a sphere. I am missing something here, and I apologize. Hold on a second. Why am I not allowed to feed in the sphere into my dynamic collider? Let us consult the all-knowing, all-powerful documentation. Sometimes, yeah, okay. Ah, I was right. I was going the right way initially. Jeez, see, this is what happens when I don't listen to myself. And it's got to be a passive rigid body. Okay, awesome. There's our solver. Okay, the output of our solver. There it is. You're absolutely right, Mr. May. So I got to take the solver information, send it over here, and now, yeah, there it is. That was the one piece I was missing. I wanted to take the output of the solver and put it into the particle simulation. Now they're bouncing off each other, which is a whole lot of fun. A whole lot of fun. And you can go in and start modifying a lot of these effects to get some really cool things. So let's see what happens when we add a replicator into the mix, and maybe we have a whole bunch of little cubes popping in and out here. So let's do add item, particles, replicator. Throw a cube into the mix. That'll be the prototype. I'm just going to scale this guy down in component mode because I want a whole bunch of cubes. And then the replicator will take the prototype to be the cube. The point source will be the particle simulation. Boom, 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 boom. Pretty cool. I love it. I love it, I love it, I love it. It's pretty neat. However, the one thing that we're really not simulating at the moment is a sense of rotation. And I would like to have rotation if possible, okay? I would like to kind of create the illusion that these things are falling and rotating within our scene. So thus enter the role of particle modifiers, okay? And as I was mentioning before, particle modifiers are going to change the way these particles behave within the scene. And it's an incredibly powerful extension to the Modo particle system. And we can add, there's a whole bunch of different type of particle modifiers. We're going to just start off with a generator, okay? Or excuse me, a basic one, I apologize. A basic one, that one right there. Basic particle modifier, let's throw it into the mix, okay? Now particle modifiers, and I am grabbing the wrong one. I meant to say particle operator, excuse me. Particle operator, that's what I wanted. Particle operators are rad. I like particle operators. And as you can see, what's going to happen here is that they're going to feed information in to the particle simulation, which then sends all of its information over to the replicator, which gets its source information from the cube. Okay, particle operators are pretty rad, but we need to assign features to the particle operator to define how it's going to influence the simulation. So let's do add feature. And I think what we're going to do here, and there's a lot of features to this, and so I gotta apologize, okay? In order for us to change, so these are all the different features of a particle that we can use to influence other parts of our crazy simulation, and it's overwhelming. Some of these I don't even know what they do, okay? But the one that we want to kind of zero in on is angular velocity, okay? We're going to add the angular velocity into the mix. Angular velocity, and notice that I've checked on add to schematic, and then it shows up there. We're also going to add in the particle identification number. ID read only. Hit add to schematic. There we go. All right. So with that set up, what we're going to do, and this is kind of strange and weird and wacky and wonderful all at the same time. Each particle, the moment they're born, is assigned its own unique identification number. We can't stop the system from doing it. This is the only way for us on the back end of the particle system to define and make each particle unique from one another. Okay? So we're going to tap into that. We're basically going to take each identification number, so the physical value that particle has been assigned, and we're going to tell the computer to assign that number as the rotation value for that object. So let's do it. Drag and drop over there. There we go. So I'm just rotating the X, or my little cubes along the X axis now. Let's see what we get. A little bit, yeah. Now they're rotating, and they're continuing to rotate and fall along our scene. So if we continue, maybe what we can do here is that we can take the particle ID number and feed it into both the angular velocity on the X, Y, and Z. And now our little particles are going to be tumbling as they hit and strike the surface of our sphere. Yeah, pretty cool. Great way to simulate and continue to modify how much, or just get some rotation along our particles as they're falling. They're not rotating very much though, right? I need to go in and modify how much rotation they're getting as they're falling across the scene. And that's where the math modifiers really come into play here. And I like modifying the math a little bit because it puts me in the driver's seat as to a number of the numeric equations that are influencing my sim. Excuse me. So I want to intercept this particle ID value. Okay. One of the cool things that we can do in the schematic is that we can right-click on it and we can separate the channel into its own node. There we go. Okay. And I basically want to change the math in here. Maybe I wanted to take the number that was automatically assigned to the particle and multiply or divide it by a certain number to influence the rotation amount that's coming across inside of our simulation. So it's pretty cool. So what we can do here is that we can go to the top of our schematic, go add, channel modifier, math, and let's just do a basic divide. There it is. There it shows up. Okay? And I want to take the output right there. This one's going to go there. So now we basically have intercepted that signal, and its number, its value is being handed off to this math modifier. We need to tell it at which percentage or at which rate to divide the value. Let's just divide it by 2 and send it back. See what we get. You know what I'm going to do here is I'm just going to remove those connections altogether, just so it's really easy to see the effect of that math modifier. Let's see. And it doesn't look like it's rotating it very much now, just very, very small amounts. So what if we divide the value by 0.25? Go the opposite direction. Yeah, now it's really rotating as they're coming out of the particle emitter. Okay? So let's do the exact same thing on the other 3. And now we're going to be able to craft a system that will allow us to very, very quickly change the rules. Here's kind of a cool little trick. If you wanted to add a node in between one of these guys and one of these guys, if you select the noodle, you can go add channel, math modifier, divide, basic divide, and it'll automatically kind of hook them in for you. It's kind of neat. And then we can do, maybe we wanted to rotate it more along the y values than any others. Let's do like 0.1. Last but certainly not least, let's get the z action in there. Add channel modifier, basic math, divide. Well, that's not divide, that's maximum, so let's change it to divide. There we go. This one will be 0.25 as well. Let's see what we get now. Woo! Random rotation. Awesome. Good times. Very cool. Very cool. I like it a lot, actually. It's doing some really neat things. No. No, unfortunately not. Unfortunately not. You can colorize things, though. So if you want to have things be labeled, if you select them over in the item list, we can assign them an editor color, like red, for example. And then you can see that those elements are going to be outlined in red inside of your schematic. So that's kind of handy. That's kind of handy. But that's about the only thing that you'd want to do. You can group things, but that's getting pretty complex pretty quickly when you start grouping sections of your schematic. Yeah, not impossible, but it's not easy to work with either. It's, to be honest with you, it's one of my more frustrating areas of working in the schematic is just grouping things into small little bundles. Okay. Okay. Questions? No, everyone's good. Everyone kind of understands the basics of working inside of Modo, or inside the particle system inside of Modo. Your brain broke? Okay. Well, today was I just wanted to introduce the idea to you guys. I know that there's a lot of moving components in here, but I wanted just to show you that you can do this, that it's available to us. We can render it pretty easily. Next week, we're going to extend it a little bit more, okay? And we'll have some fun before we break for Thanksgiving, okay? Yeah, I have this really cool Ring of Fire exercise that I want to show you guys. It's pretty neat. It's going to take everything that we learned kind of today and put it into action next week. So next week we'll have a nice chunk of lab time to play around with particles. Okay? I want to stop right now and give you guys an opportunity. We've got about 45 minutes left in class to continue working on your animatic for your final project if you haven't finished yet. It's important that we keep moving forward, and I know you guys have a lot of questions for me, so let's use this time wisely. Okay? Let's get to work.